Hello students, in this video we will study Unit 1 some basic concept of chemistry. The syllabus is based on your NCERT syllabus and as you know we have to cover the following topics. First, general introduction, importance and scope of chemistry, historical approach to particular nature of matter, laws of chemical combination, Dalton's atomic theory, atomic, molecular and empirical masses, mole concept, percentage composition and empirical and molecular formulas, and lastly chemical reactions, stoichiometry and calculation based on stoichiometry. So this is the first part. Here we will study about the matter. Before starting study about the matter, there is a general introduction. That means science is defined as a systemized knowledge gained by mankind through observations and experiments, and it has been classified into different branches due to its numerous expansion and diversified fields. So chemistry is one of its important branch which deals with the study of matter, its composition, properties and changes which it undergoes in composition as well as in energy during various processes. So its importance and scope. Chemistry plays a very significant role in almost all walks of life. It's very useful in agricultural purpose, in industries like synthetic fiber, plastic, paint, varnish, cement, glasses, optical fibers, etc. Chemistry is also very important in the field of medicines, and its energy resources of the world are petroleum, coal, wood, nuclear fuel, etc. So its application is very wide in range, and we are just here to discuss from matter. It can be, see, the universe is made up of matter and energy. So here we will just discuss matter. So matter is again classified into two kind. Physical, on the basis of physical classification, it may be of solid, liquid and gases. So solid, liquid and gases, I think you all know about the solid, liquid, gases because in lower classes you already studied this topic. These are the three physical state of matter, and the on the basis of chemical composition and chemical properties, they may be of two type: pure substances and mixture. So first, pure substances. Pure substances is again classified into element and compound. So element, periodic table में आप जितने भी symbol देखते हैं, they all are the element. Element actually cannot be prepared. Element is already present in nature. ये हम बना नहीं सकते. But compound can be prepared by using elements. They are the combination of elements. So elements on the basis of nature, elements are again classified into metal, non-metal and metalloids. And compounds are classified into inorganic compounds and organic compounds. And here mixture are again classified into two types: homogeneous mixture and heterogeneous mixture. So what happens in homogeneous mixture? Homogeneous mixture, the solute and solvent both are uniformly distributed. Means अगर हम कोई two or more than two compounds या element या कोई भी matter को mix करते हैं in any proportion, then it form homogeneous. It may be formed homogeneous or heterogeneous mixture. Suppose we are taking water and salt. Water is liquid, salt and solid, and their physical appearance is totally different. But whenever they are mixed together, salt is uniformly distributed all over the water. So that is the example of homogeneous mixture. And what happens in case of heterogeneous mixture? Suppose you mix water and sand, so they are not miscible and they retain their phases. वो जिस phase में है वो वैसे के वैसे रहते हैं, and there is no uniformity in their distribution. So they are known as heterogeneous mixture. Many properties of substances are quantitative in nature. Such properties, this is not such, you can correct, this is such, such properties are known as physical quantities. So what are the physical quantities? The quantities like length, mass, time, temperature, area, volume, density, etc. which can be measured, मतलब जो भी property को आप measure कर सकते हो, they are known as physical quantity. So physical quantity is represented by number followed by a unit. Means जब भी हम इसका measurement करेंगे, so its representation will be in a number which will be followed by unit. So that means number plus unit is known as magnitude of the physical quantity. For example, if an object length 5.6 meter, so here there are two parts. The first one is 5.6, it is the number, and meter, it is the unit. So number plus unit is known as physical magnitude of the physical quantity. So in order to measure, we require unit. So there is an international system of unit which is shortly known as SI unit. A unit is a quantity or a dimension used as a standard of measurement. The international system of unit called SI unit, in short हम इनको short में SI unit बोलते हैं, but this SI unit is derived from a French name System International de Units, which means International System of Units. So here there are total 7 basic units, and you must know what are these 7 basic units. The first one is length, its symbol is L and unit is meter, and the symbol for unit is small m. Mass, symbol of mass is m, but it is measured in kilogram, kg. Similarly, time, T, and measured its unit is second, S. Electric current, I, its unit is ampere, symbolized by A. Temperature, denoted by capital T, and its unit is Kelvin. Amount of substances, that is N for number of mole, and its symbol for SI unit is mol, mole. Luminous intensity, represented by IV, and its SI unit is candela, represented by Ct. So what are the basic unit? The units whose value is not dependent on other kind of unit. They are totally independent. उसको हम बोलते हैं basic physical quantities or basic units. But there are many other quantities which are derived from the basic quantities. They are known as derived quantity. The SI system of measurement, such as given units for the 7 basic quantities which is listed in the previous slide. The units for other physical quantities such as area, volume, density, force, pressure, acceleration, velocity, etc. can be derived from the SI units by applying suitable mathematical calculations. Means for derived units, they are not independent. They are based or derived from the previous 7 basic units. These are called derived units since they have been derived from the basic SI units. यही same thing जो मैं अभी आप लोगों को बता रही थी. Here there are some examples listed. These are the examples of derived units like area, volume, density, velocity, acceleration, force, pressure, work, energy, frequency, electric charge, electric potential difference, electric resistance. So ये जो quantities हैं, these are actually derived quantities because there is a specific formula for these quantities. But अगर आपको किसी का length calculate करना है, then simply you use a scale और a tape and directly आप measurement करके उसकी length जो है वो calculate कर सकते हो. But suppose if you want to calculate the area, then आपको क्या करना पड़ेगा? Length into length means length into width. अगर आप ऐसे करोगे, then you will be able to calculate area. So it will be meter square. Similarly, volume, meter cube. In case of density, which is mass per unit volume, so for mass it will be kilogram. That means density is a derived unit which is dependent on mass and length, right? तो इस तरीके से these are the derived units. The next one is subsidiary unit. Quite often we require units that may be multiplies or fractions of the base unit. The SI system recommends the multiplies such as 10 to the power 4, 10 to the power 8, 10 to the power 10, etc. and the fractions such as 10 to the power minus 4, 10 to the power minus 8, 10 to the power minus 10, etc. That is the powers are the multiplies of 2. So these are indicated by special prefix. These along with some other fractions or multiplies in common uses along with their prefix. So here some common prefixes are given such as deci, it's 10 to the power minus 1, For example, 1 decimeter will be equal to 10 to the power minus 1 meter. Similarly, centi 10 to the power minus 2, milli 10 to the power minus 3, micro 10 to the power minus 6, nano 10 to the power minus 9, pico 10 to the power minus 12, femto 10 to the power minus 15, auto 10 to the power minus 18, zepto 10 to the power minus 21, yecto 10 to the power minus 24. But there are some others also, like 10 to the power minus 10, that is called angstrom. 10 to the power minus 10 meter is equal to 1 angstrom. Similarly, the larger units like 10 to the power minus 1, deca, hecto, kilo, mega, giga, tera, penta, exa, zeta, iota, etc. So for this video, that's all. Next topic will be measurement in chemistry, significant figures, some problems based on significant figures, and laws of chemical combination. So thank you.